So, good afternoon, class. Today we're going to discuss the first lesson we have in physical science. Okay, so as you can see in the screen, we're going to talk about the formation of heavy elements in Module 1. But first, okay, in this specific lesson, we're going to discuss on stellar nucleosynthesis or the rise of the stars. So first, you should have answered the what I know part, and of course, the assessment in the last part later on. So, in this lesson, we know that the world where we live today is just a small part of the universe. So in our previous years, you have learned about the different theories of the origin of the universe that eventually led to the formation of galaxies, solar system, and other heavenly bodies. Now, we'll focus on one of those wonderful things, okay, present in our outer space. We have the stars. So, although stars are millions of light years away from us, we can still see them twinkling in the night. Why is that so? So, ayan, let's move on to this discussion. Paano nga ba nag-form ang universe? That is the big question, okay? And according to scientists, they believe that the formation of universe is based or began through the explosion of a primordial atom, which happened 13 years or 13 billions ago. Okay, so it is known as the Big Bang. Take note that it became a theory that also explains the continuous expansion of the universe. So Big Bang has stages. We have singularity, the expansion, and nucleosynthesis or stellar nucleosynthesis. Okay, so right after the Big Bang, okay, so under the nuclear synthesis or stellar synthesis, protons and neutrons combine together to form the light elements. So, protons and neutrons came from the explosion from the Big Bang. Okay? So, these two protons and neutrons, okay, form the light elements such as the hydrogen and helium through the process of Big Bang synthesis or Big Bang nucleosynthesis. So, lithium and beryllium were also formed during this process. Take note that hydrogen has one proton. Okay? So, parang substitute ng proton si hydrogen and the other way around. Okay? So, when proton and neutron combines together, it will form deuterium, as you can see here. Okay? So, deuterium, kapag nagkaroon ng additional of deuterium and other proton or neutron, there will be another element to be formed. Okay? But before that, let's first have this. Okay, yan. So, this diagram, paano nga ba nagkakaroon ng iba't ibang elements? Okay? How are elements or light and heavy elements formed? So, the diagram shows the proton-proton chain reaction in the main or in a main sequence star. So, this is a process by which average star gets their energy and convert hydrogen into helium. So, proton plus proton will, proton and neutron, okay, proton and neutron will form what? Will form deuterium. proton plus neutron, when fused together, will form deuterium. Then, if one proton collides with deuterium, okay, it will form helium-3. And when helium-3 fused with another helium-3, okay, or two helium-3 collided, will form helium-4. Okay, so how is that? Diba napakahirap intindihin kung, ayan, nasa picture lang. But, ito, ang gawin natin. Wait lang. So, doon kanina, kapag daw pinaghalo or when proton, okay, when proton plus neutron or proton fuses with neutron, it will form deuterium. Okay, take note that proton can be a substitute of hydrogen because they have 1. Okay, positive 1. So then if deuterium, okay, if deuterium will be fused with another proton, okay, kapag nag-fuse siya ng another proton, it will form helium-3. And if helium-3 is added to another helium-3, it will form helium-4. Okay, so that is the proton-proton chain reaction. So it starts with 2 proton, and then if it is added, or if the proton will be fused with the neutron, it will form deuterium. And if deuterium fuses with another proton, it will form helium-3. And if helium-3 are fused together, okay, it will form helium-4. Okay, so those are the isotopes of helium. Alright, so, but in case is different, no? And massive star or star 8 times larger than solar mass. So they undergo CNO or carbon, nitrogen, oxygen cycle to convert hydrogen or the proton, okay, into helium. So as you can see at the right here, okay, so when carbon 12 fused with proton or hydrogen, it will form nitrogen 13. So carbon has the superscript of 12 or the atomic mass of 12. If it is added with another with 1, it will result, or the sum will be 13. So what element has this atomic number, I should say? Okay, what element has this atomic number? None other than nitrogen. Okay, so nitrogen 13, when it undergoes beta decay, okay, so beta decay, the formula or the representation for beta decay is, the representation of beta decay is okay. So when nitrogen 13 undergoes beta decay, it will form carbon 13. Then when carbon 13 captures proton, and nitrogen 14 will be formed. Alright, so as you can see in the diagram, no, when nitrogen 14 captures proton, so plus 1, So we'll be having oxygen 15. And if it undergoes beta decay, it will form nitrogen 15. Ayan. So nitrogen 15, when fused with another proton, it will give off helium and end up with carbon 12. So bumalik siya doon sa pinakauna. So then the process repeats again. That's how these elements are produced, through the process of carbon-nitrogen oxygen cycle. So that is how helium is produced, I should say. Alright, so in tri-alpha process, it happens only in red giant star once they leave the stage of main sequence star. And this is how 3 helium-4 are converted into carbon. So, kanina, saan po na-produce or paano na-produce ang helium-4? That is through the collision of 2 helium-3. Okay. So, when there is triple A process begins when 2 helium, which has the 4 atomic number, okay, or nuclei, fuse to form an unstable beryllium element. And if that beryllium element fuses with another helium-4, okay, it will produce carbon 12. And how do we get or how do we produce helium? Take note that the star is made up of helium, millions of helium. Okay, so carbon will be converted into helium through the process of what? Through the process of C and O cycle. So from carbon, naging helium siya. Okay, let's move on. A star accumulates more mass and continues to grow into red supergiant. And when alpha particle fusion happens at its core and creates more heavy elements until iron. And that is now known as the alpha ladder process. So in here, heavier elements will be formed. So as the energy at the core of the star decreases, nuclear fusion cannot produce elements higher than iron. So, syempre kapag nagre-reduce na yung or nagde-decrease na yung energy, fusion cannot take place or cannot produce elements higher than iron. So, different pathway is needed for heavier elements to be formed. And that is through neutron capture. That is one way. Okay, so how is this happening? Or how will it happen? So neutron capture is a neutron when a neutron is added to a seed nucleus. Below is the representation of how neutron is captured and heavier nucleus is formed. So that is the representation. So for the representation of neutron capture, as you can see, we have this one. We have this. Okay, that is the representation of neutron capture. So, neutron capture can be slow or rapid. So, S process or slow process happens when there is a slow rate of capturing neutron while there is a faster rate of radioactive decay, hence increasing the proton by 1. So that is the example. Okay, and if there R process naman, kapag rapid process, means that there is faster rate of capturing neutron before it undergoes radioactive decay, thus more neutrons. Okay, magkaiba ha? Neutrons can be combined at the nucleus. This is what happens in a supernova forming heavier elements than iron with the process known as the supernova nucleosynthesis. So, for example, in the neutron capture, if iron undergoes neutron capture, so it will form an isotope of iron having the 59 atomic number. Atomic mass, I should say. Okay. So the explosion of star or supernova is believed to be the source of other elements heavier than iron. So during the explosion, these heavy elements are dispersed into the space, and aside from gases, hydrogen, and helium in space, other evidence of star formation is the energy emitted during the nuclear reaction. So it is also the energy emitted by different forms of radiations, such as UV, infrared, X-ray, radio wave, and microwave. So in your activity, you should have answered those activities that are not included in the answer key. Okay? Those answers, yung walang mga answers sa answer key ang dapat ginawa ninyo. So, if you have questions, yan, or if you have more questions, I can cater those after this video.